That light switch over there when you're over there. Sweet. All right, let's run through any of the problems you might needed to go over. Were there any problems from the assignment you'd like to see?
Yes.
Yes, okay.
Like 80.
Like what?
80.
80? Okay, let's start there. Okay. Cell phones away, please. Video game contraptions away, please. Talk about cell phones and video games?
Yeah.
What, are you trying to throw people under the bus?
I mean, I've never seen anyone in here use a cell phone.
Yeah.
Neither have I.
What's a cell phone?
I'm just trying to do proper protocol just in case it were to happen. You know, because every now and then. Yo!
Oh, now we'll
I got
see
you. Thank you.
Best day ever! Thank you!
What kind of donut? Donkey donut? Oh,
Alright. Here we go. Ready? So, problem number 80. Come on, you guys are being bad. Says, what does Descartes' rule of science tell you about the number of positive real zeros and the number of negative real zeros in the function? So, are we solving for the positive and negative real zeros? Do we want to try and find them out? Or do we just want to know how many possible positives and how many possible negatives do we have? Okay, now, I got a question. Do we know how this problem is set up? Guaranteed what one of the zeros would be right away. 0. Why 0? I have a greatest common factor of x if I factor x out. So one of my zeros, one of my definite zeros to this problem is just 0 because each one of these has an x in it, which that indicates it will cross right at 0, 0. So if I know that, how many other possible zeros will there be on this problem? If I know one of them 0, 0, how many other possible real zeros will there be? I'm not looking for a real positive, though. What's my highest exponent? 6. So how many zeros should this have? It should have 6. We know one of them, so there should be 5 left. Does that make sense? All right, so let's take a look. Let's find, so what we're going to do is we want to find the zeros over here. So those are our real positive zeros. So what we're going to do is we're going to look at the original equation. We're going to see if we have any sign changes. So this is positive, so I have a sign change here, and I have a sign change here. So we have 2 or 0 positive zeros, meaning it happens to the right of the y-axis. And then I'm going to go and I'm going to change all of my x's. I'm going to plug negative x in. And so I have 5 negative x raised to the 6th power minus 3 times negative x raised to the 3rd plus negative x squared minus x. So if I were to take negative x and plug it in and raise it to the 6th power, does the x stay positive or negative? It becomes positive. So this is 5x to the 6th then. Okay? If I were to take negative x and raise it to the 3rd power, so I have negative, negative, negative. If I multiply that together, what do I get? Negative. And then I have the negative out here, so what does that do? Makes it positive. And then I have this. What does this one become? Positive. And then this. Okay? Do I have any sign changes there? So positive, 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 positive. Any sign changes? So over here, I have 0. I have 0 real solutions. It will not cross the x-axis to the left of the y-axis. So I know this problem will cross, it'll cross the 0, 0, or the origin, because everything has an x in common. And then on the right side, on the blue side, on the positive side, it will cross 2 or 0 times. Okay? And that's all we have to do for the problem. What other problems do we see? Yeah. 46. Number 46. All right. If 2i is one of the solutions to the problem, what else would be a solution to this problem? Negative 2i. Good. Remember, if you have i's with it, they come as conjugates of each other. So those are the two solutions. So you have to think about what would I have to have gotten to in order to get there? If my solution was 2 and negative 2, it would be x squared minus 4. God bless you. So x squared minus 4, if I were to solve that, I would get plus or minus 2. So what sign do I have to change in order to get to 2i? Plus 4. So this gives those two answers. This is raised to what power was the highest exponent? The fourth. So how many more solutions are there to this problem? 3 or 2?
3 or 1.
What do you think? Is it 3 or 2? One's not part of it. Why is it 2? Yeah, this is a solution, and that's a solution. So there's 2 of the solutions. That's raised to the 4th power, so there's 2 more solutions to this problem. Being that you had the I, don't go and synthetically divide using I. Use the long division on these. So I'm going to go x squared plus 4 into x to the 4th minus 16. What should I do to x squared? What should I multiply by x squared in order to get x to the 4th? X squared, okay? So x squared times x to the 2nd is x to the 4th. X squared times 4 is negative, or positive 4x squared. Okay, subtract. So that's going to cancel that. Then I'm going to get minus 4x squared down here. And then minus 16. What should I multiply x squared by to get negative 4x squared? Negative 4. Negative 4 times that is negative 4x squared. Negative 4 times that is negative 16. Again, I'm going to subtract everything, so everything cancels out. So here's my first solution, or binomial. The other one is going to be x squared minus 4 equals 0. So x is equal to, x squared equal to 4. So x equals positive and negative 2. So the two binomials you put together in order to get x to the 4th minus 16 are x squared plus 4 and x squared minus 4. Your solutions to this problem are 2i, negative 2i, positive 2, negative 2. Okay? Any other questions from the homework? You okay about it? 8, I'm sorry? 8, 2, yeah. Okay, first question. Does this cross at 0, 0? Does this cross at 0, 0?
No.
No, why not?
Because it's not like it's not x. There's not an x that you can factor out.
Yep, there's not a greatest common factor of x. First thing I want to do, I want to know if it crosses on the positive side of x. So I have all negative signs. Do I have any sign changes? No. So I have 0 real positive solutions. It will not cross the x-axis to the right of the y-axis. It will not cross any positives. So then I'm going to take negative x, plug it in. So I'm going to get negative 3, negative x to the 5th, minus 7, negative x to the 3rd, minus 4 times negative x, minus 5. If I had negative x raised to the 5th power, does this produce a negative x to the 5th still? Yep. And I have a negative out here, so that's going to become positive 3x to the 5th. If I have negative x to the 3rd, does that result in a negative x to the 3rd still? Yep. There's that negative out here too, so it's going to be positive 7x to the 3rd. What does this give us? Positive 4x, and then minus 5, right? So we're looking for sign changes. I got one sign change. So we have one solution, one real negative solution. So it'll cross the x-axis on the left side in the negative region. What can you tell me about the other 4 solutions to this problem? They're not real. Hey, would that make sense to have 4 solutions that are not real, that are complex? Yeah. Would it make sense to have 3 complex solutions? No. Why not? They come in what kind of pairs? Conjugate pairs, so opposite sign pairs. Okay? So, here's the nice thing about when you're dealing with something that's raised to an odd number. At least one of the solutions is going to be real. All the rest can be imaginary or part of the complex number system. But if it's raised to an odd number, you will have at least one real solution. Whether it's positive or negative, I don't know. Okay? So I have one real negative solution, 0 real positive solutions. Are there any other questions from the homework? Okay with it? Okay. Make sure your name is on whatever you're handed in, please. I want to move on. This one? No, the one that. Well, 9 News might be here.
What?
What? For the med class.
9 News is coming on. I'll be here tomorrow.
Possibly. Okay.
For what?
Med class. For good stuff. All right. All video game contraptions away. I know they don't exist in here, like y'all said. All right.
That man likes to talk.
Yeah. Turn off those lights?
Oh, yeah.
Oh, you want to dock? Dock? All right. So, taking a look at this equation. Without using a graphing calculator, well, no, you can't read. He just doesn't care. Not right now, no. It's from Parker. Of course he can't read. All right. Without graphing this on a graphing calculator, what are some thoughts you might have about what the graph might look like? It's going to be negative, so it's probably flipped somehow. Is that okay to say that? What else? Yeah. Could be open on its side. Is there any value or values that it probably can't equal? Why can't it equal 0? Can't have 0 in the denominator. So I know this is not going to take place. I talked briefly yesterday. Sometimes you could have an asymptote, and sometimes you could have a hole. Do you think there's a hole here or not? No. Does anyone know when a hole will take place?
Yeah, the same factor that's marked.
Good. So a hole happens when same binomial on top and bottom. Okay? So this isn't going to happen because I don't have the same binomial. I don't have a binomial anywhere. I don't even have the same factor on top and bottom, so we're not going to have a hole on this. I think we could have an asymptote. I think we could have a vertical asymptote to this at 0. But I also think we might have a horizontal asymptote. Any ideas? Huh? It's cold. Turn the lights off so that. You see any horizontal asymptotes that might happen? Now I'll remind you that horizontal asymptotes happen in 2 of these 3 situations. Yeah. Scenario 1. Thank much. Scenario number 1. The highest degree on top is less than the highest degree on bottom. The highest degree on top is equal to the highest degree on bottom. Highest degree on top is greater than the highest degree on bottom. What do we have on this situation? We have highest degree on top, equal degree on top, bottom, highest degree on bottom. Yeah.
Oh,
Good.
I know what happens.
Good. Yeah. Do we have highest degree on top, highest degree on bottom?
Highest degree on bottom.
Highest degree on bottom. Okay. If the degree on the bottom is larger than the degree on top, you will have a horizontal asymptote of what?
Y equals 0.
Y equals 0. Good. Okay? I have a vertical asymptote at x equals 0. Okay? Now this asymptote can change easily, but here I can't allow x to be 0. So if I had a graph like this, I'm going to have an asymptote. I'm going to have an asymptote here. And I'm going to have an asymptote here. So let's think about this. If I were to plug -1 in, I get -1 squared, which is 1. So I have -1 over 1. So if I plug -1 in, I get a -1 out. What if I plug a +1 in? I get 1 squared, which is 1. -1 over 1 is negative. So this is what my graph's going to look like. Okay? So that negative changes it. If I didn't have a negative out front here, it would have just flipped over. So the negative out front here means it flips over the x-axis. So that's the first part. Let's try another one of these problems. Let's see if we can talk through it a little bit better. What if we had what should we do? Do what?
Same over same.
What do you mean same over same?
Doesn't that
Is it a hole? Okay, could be. I don't know yet though. Do what? Oh, I like it. So we're going to say right now we have a horizontal asymptote. Horizontal asymptote. The lead coefficient here is 1. The lead coefficient here is 1. The highest degree on top is equal to the highest degree on bottom. So it's whatever those lead coefficients are. So my horizontal asymptote is going to be y equals 1. I like it. Do we know if we have any holes? Factor it, okay? So what does this part factor to? Good. X plus 2 and x minus 2. Can I factor the bottom as well? What two numbers multiply give me negative 6, add to give me negative 1. Two numbers add to give me negative 6, negative 3, and positive 2. Which one of those will describe a hole? Because these are the same right here. That's going to generate a hole at 2 comma what?
I think it's a positive 2.
It is a positive 2. That's why I have positive 2.
2, 1.
No, like
0.
factor. Yeah, it's factor.
I'll put it back in.
X minus 2.
Oh, that's a plus? Ooh. Uh-oh.
So it'd be negative 2.
So that's the hole. I'm going to skip that. Make that a negative 2. Thank you, thank you, thank you. So what I have left is x minus 2 over x minus 3. Where is this hole taking place? Negative 2 comma what? So on top I have x minus 2. That's negative 2 minus 2, which is what? Negative 2 minus 2 is what? Negative 4. On bottom I have negative 2 minus 3, which is? Negative what? 5? Positive. So at negative 2 comma 4/5, I am going to have a hole in my problem. Does that make sense? And then, do I have any vertical asymptotes? What do I have left? What do I have left over there? What do I have left in blue over there on the right? X minus 2 over x minus 3. What value is going to make it undefined? 3. So my vertical asymptote is going to be x equals 3. Okay? So that's going to, we're going to take this and let's make our whole, let's draw a problem, having our asymptotes. Okay? So I have a vertical asymptote at positive 3. That's a result of the denominator. So I have 1, 2, 3. And we'll do that in. So there's my vertical asymptote. My horizontal asymptote is at y equals 1. And that's because the degree on top is equal to the degree on bottom. So the lead coefficient of x squared on both of them is 1. So it's 1 over 1, so y equals 1. So here, okay, so there's my horizontal and vertical asymptotes. I found that I have a hole at negative 2 comma 4/5. So if this is 1, is 4/5 above or below that? Below it. So at negative 2, 4/5, I'm going to have a hole. Any idea what this graph is going to look like? I think this is part of it. So do you think it's the vertical angle to it, or do you think it's the mirror image over the x-axis? Vertical angle? So how would we check? Plug in what? You're absolutely right. What should I plug in, you think? Yeah, so let's plug something that's going to be to the right in. So let's pick positive 10. 10's easy to plug in, right? You don't have any weird stuff that 10 does. So if I were to plug positive 10 in, I get 10 squared, which is 100, minus 4, so I get like 96. And then I get 100 minus 10 is 90, minus 6, 84. So 96 over 84, is that bigger than 1 or less than 1? It's bigger. The numerator is larger. The top is larger. So if I had 1 here, so I'd say this graph is doing something like this. There's a hole on one side right here. Remember the hole, it's going to skip over. Okay. Now, this graph is not going to have something called an end behavior asymptote, but we will get there. An end behavior asymptote is also called the oblique asymptote. Okay, so let's find something that has an end behavior asymptote. Or am I even teaching that today? Probably not even teaching that today. Maybe I am. Good guess. Okay. Can I move on? Yeah, buddy. Okay, let's go through our things that we know. Is the degree on top larger than the degree on bottom? We agree? Does everyone agree with that? The highest degree on top is bigger than the highest degree on bottom. We have no horizontal asymptote. Because the degree on top is greater than the degree on bottom. Is that okay so far? So we don't have a horizontal asymptote. I think we might have a vertical asymptote, but let's see. Is there the right thing? Let me just make sure. It's all there. Does it look like it's going to necessarily factor? I mean, things that I know on top, if I factor the top out, I know I'm going to get this. And then if I factor bottom, we'll change black on this. If I factor bottom, it looks like I can take a 2 out and get x squared plus 2. Okay? I don't know why that made that. It did. So no horizontal. Vertical asymptote? Vertical asymptote. What's going to make the denominator equal to 0? How do we know? How do we find it? Huh? Plug it in? Nope. How do I find where the denominator is equal to 0? Set it equal to 0. So I'm going to get 6x to the 4, or 6x squared plus 4 equals 0. I'm going to subtract 4. Shh, I'm almost done, everybody. X squared minus 4 over 6. So x is equal to plus or minus 2i over root 6. What can you tell me about that? It's imaginary. Is there a number we can plug into the denominator that'll make it 0? Think about it. This is squared. No matter what I plug in, I'm going to get a positive number out. Even if I plug 0 in, 0 squared 0 times 6 is 0 plus 4 is 4. Okay? I'm not going to have a vertical asymptote. I'm not going to have a horizontal asymptote. I don't have a hole because I didn't have the same binomial top and bottom. But I probably have an oblique asymptote. An oblique takes place when the degree on top is greater than the degree on bottom. And what you're going to have to do there is what you're going to do here is you're going to take the bottom, 6x squared plus 4, and go into the top. So what do I have to multiply times 6x squared to make it 12x to the third? 2x. 2x of that is 12x to the third plus 8x. I guess I can subtract. So that's 0 minus 9x. So this right here, y equals 2x, is my end behavior asymptote. So what does y equals 2x look like? Algebra 1, first semester. What kind of line? Straight. Where does it go through the, where's the y-intercept? 0, 0. What's the slope? 2. Up 2, right 1. So this is going to be my end behavior asymptote right here. Okay? So at the ends of this, our graph's going to follow it. Any idea what this graph is going to look like? I mean, that's a tough thing if you don't have a calculator. But I'd say this is probably going to be some weird graph that probably looks something like this. It doesn't cross over. Something like that. Where the ends, that's approaching the end behavior. I'd say that's going to be the graph. Okay? So, for tomorrow, this is going to be a two-part assignment for tomorrow. So I want us to work on page 316. Let's do 7 through 25, every other odd. Is that okay? And that's all I'll have for you for tomorrow, and then we'll do some more. Deal?